Well, good evening. Just thought I'd do a quick video on some calibration stuff that I'm doing with respect to my 461A amplifier here. I had actually started work on it. As you can see, I have the top off. I had started work on it before it occurred to me that, I should do a little video. So let me explain a little bit about the unit and what was going on. Here you can see the basic layout of the unit. Let me zoom in a little bit so you can really get in and see the electronics here. This is basically a set of amplifiers. It's an emitter follower at the start, emitter follower at the end, and then a set of cascaded amplifiers in between that give about 40 dB of amplification. And so if we come and have a look here at, let me just zoom this in a little bit so you can see it. Zoom. Why I'm using my tablet will become obvious just a little bit later. Here you can see the basic block diagram. We take an input signal, we go into or through an attenuator that can be switched in or out. Then we go into the emitter follower, then the cascaded amplifiers and the emitter follower on the way out, and then off to the output, and they're all powered by the primary power supply. Now the whole aim of the emitter followers is basically to get that impedance match correct, so that they're nicely 50 ohms at either end, and then the amplifiers in the middle do the 40 dB of amplification. And when you want 20 dB of amplification, the attenuator is basically a 20 dB attenuator at the front of the whole process. So that's the basic block diagram. Let me put that aside and zoom out a little bit and show you what I was doing. So I had my network analyzer going. I thought, well, I should check out and see what my amplifiers are doing. And ideally, if this was a perfect amplifier, I would have a straight line at the 40 dB power level showing the gain of the system. Now my network analyzer here has the 60 dB attenuator into it, so I can actually step it down, the power output down 40 dB, then stick it into the amplifier and then step it back up 40 dB. But that should basically be a flat line. Now you can see that as it comes down, I'm just dropping below sort of half a dB at a couple of points in terms of the flatness across the 0 to 150 megahertz range. So that is just outside of spec there and there, because at 40 dB it's supposed to be, the 40 dB amplification, it's plus or minus half a dB. And then if I go in and have a look at the 20 dB set, it's supposed to be plus or minus 1 dB. And you see it's closer again, but right at the end of it, it drops below 1 dB down. So I went and had a look at the test. Let me just take that out of the road and put this in here. And now if you have a look at the test, this is the frequency test. Basically what I can do, and if we zoom in a bit here, you'll see that I'll be able to get the frequency response L2 through L6 unless some of the components have changed. Well, they have changed, so I need to come in, and if we look here at B, it tells me that as we're seeing the specifications at 50, at 100, 75 to 120 to 100 megahertz, we're starting to see roll off that I should be able to tweak L2, L3, L4. Now, when we go and have a look again at these items in here, these are the various inductors that you're going to go tweak. So now let's have a look at the numbering of them. And so here we go. Let's zoom that out a little bit. You know, from the front of the unit, which is over here, you know, we start off with L6, then we go L5, L4, L3, and then L2 right down the back here. And so what these are, and let's see if I can zoom right in on one and get it, you know, it really doesn't want to, there we go. That's about as good as you can. What you'll see inside the center here, there's a little slug that lives inside this, these little inductor houses, and these are coil wound inductors. And you can get a tool, and like this tool that I have here, and you can use that to get in there and then turn around to set where the inductor is. And so what I need to do is just to chip out all of these, just chip out all of the wax in here that's holding the inductor slugs in place, and then we'll be able to go do that. So let me zoom back out, and I'm just going to grab my craft knife and we'll go in and make that change. Okay, what you're actually going to see here in this particular one is that there's no slug. Now, this doesn't surprise me because in my 461A, if you remember the first video, when we went and had a look, they had gone in and made some botched up fix over here on this resistor, and then on the I replaced the diode over here. But I think somebody has tried to address the gain and has removed or lost the little slug. Now if we have a look over here, you'll see what I mean by the little slug. This little slug's here, and so I can get my, let me just clean off some of this wax. I can get my connector in there, and then I can, you know, zoom it in a bit, and you'll see that now it's actually lower in the inductor, and so that enables me to tune the inductance of these items. So we're all ready now. So what I want to do now is go set up my network analyzer. Okay, so here's my 8714C network analyzer. So just for the purposes of this, I'm going to go in and I'm going to select that I want to look at an amplifier and I want to look at transmission. And so now you'll see that I have a bottom, I have a top, and I'm getting some amount of transmission through the BNC connectors that I have connected, and it's reading, if you look here, like minus 80 dB of value there. So basically that's sort of the noise floor, and if I connect these two lines together, what you'll see is that the line will go up. So if we go in and go scale and set the reference level, I'm going to make that 0. You know, we're basically now reading the uncalibrated. Now I'm not going to use the calibration tool here. I'm just going to normalize because you know, I'm just going to be looking for a flat action. But this is basically the cable through here, and so if I go in and I select normalize, you'll see that the line will flatten out. So let me go in and select the frequency. We'll start, it only goes down to 300 kilohertz, so we'll stop at 150 megahertz, and I'm going to set the power to minus 40 dBm. You know, so that's now going to be minus 40, so when it comes in, I'll be able to drive the amplifier without overdriving it. So that's what we're seeing there. So let's go back to Cal now, let's normalize again, and there we go. So now what I can do is I can now hook in my amplifier. And let me plug the amplifier in. And you'll see that that value just, it jumped way off the chart there. So let's go. So now, this reference line here at 0 is at minus 40 dB, not minus 40 dBm. So the reference level we want to see this is 40 dBm. And there we go. We're now seeing the line that's coming out of the amplifier. So I want to get it a little bit better. I know that at 40 dB I should be plus or minus half a division, so let's put in half a dB, and now you can see the lines I was getting. So if we go back and have a look at the original 40 dB value, let me see how that goes. You can see that what I'm getting here is quite different, and that's because as part of digging out all that paraffin and clearing the things, I moved the slugs around. So what we're going to go do now is go move our slugs to try and get a flatter line in the 40 dB. Okay, so let's go and get some light in here. If we go remember let me just zoom in a bit. The inductor locations, starting down the back here is going to have an impact at the low end of the spectrum, and then the high end is going to be at the front of the unit here. So let's zoom back out a bit. And now the first thing that I'm going to go do is start at the low end. And you want to use one of these when you're doing this, because these are little tuned circuits. And so you need a non-inductive tuner to go and actually move these slugs around, because otherwise you'll be adding the capacitance of your body and the metal from the screwdriver or so on into the circuit, and you'll never be able to get it to look well. What you want to do is you can just go up onto eBay and just buy these anti-static alignment tools. If you are older, you would have remembered these from back in the old days with the big television sets that were full of components, and you had to use these things to tune your TV set in properly and all that. Same sort of idea here. So what I'm going to go do now is just go in to start with L2, and we'll give it a tweak. And we'll see what happens on our value here. So now, if you remember what we were seeing before, if we come back and have a look at this, we had that nice big curve there, and this is why I wanted to use the tablet, because I can actually hit the network for the my network, or the network port on the 8714C, and get the item. And now you see that we've got a much flatter start to that. Now I'd like to tune 3 here, but that doesn't exist. So I'm going to go and see what happens when I tune 4, and then 5, and then 6, and see. Let's go back, and basically what you're going to go do is you're going to go screw around with all of these and see sort of what type of change you're going to get, and then you're trying to get you're trying to get it to be well inside the margins of the item. Now remember, we're only going to be half a dB out, so we don't want to be too high on these things, because that's going to translate to, and I wished I had that damn wish I had that damn value for 3 in there, L3, because I could really do with being able to bring that point up, you know. Okay, well, I'm not sure how well that's going to be, but let's. Okay, I think we're much closer now, much closer to where we were. So if we go and have another look here at this screenshot, you know, we're now very close around, you know, about a quarter, and then we come down to near half. If we compare that to where we were, you know, we were a little lower, but we dropped down and out. So I think our frequency, I think our frequency graph, if we take a look at that, is much better there. Let me actually just print one of those. Now, what I want to do now is go in and let's turn the gain down to 20. Let's set the reference level to 20 dB, and let's go in and take a look at where we are with that. Now, you can see a huge drop off at the end here, but we're supposed to be within 1 dB of the 20 dB line. So we are just inside the 1 dB point at the far end here. So let's just take a little touch of the slugs and see if we can get ourselves a little bit more wiggle room there. Okay, and then reference level 40. Okay, reference level 20 again. And if we go in and refresh it again, you'll see that I'm a little closer now to, you know, I'm above, right at that top end, you know, I'm just above the 1 dB line. So let me just see if I can squeeze anything else out of that. Reference level 40, reference level 20. I think that's about as good as it's going to get without having that slug there. So let's take a last look at that. Okay, and there you go. I've got like a little bit more space now between the 19 dB, but I know it's rolling off. And you know, if I was to switch it up to the 40 dB line and go look at reference level at 40 dB, you'll see that I'm just inside the half item there, the half dB thing, so we might want to just scroll that down a little bit and just accept that we're going to have just accept that we're gonna have to sort of play around, with it to try and I've done something that's upset that immensely. Okay. Well, let me play around with this a little more, and I'm going to see if I can drag it in a little better than what it was. So I twiddled around with this for a bit, and I was really unable to get the to improve upon the 150 megahertz endpoint, where it was really dropping down. And so, and I should have videoed this, but what I was doing, let me clear some of this stuff out of the road. What I was doing was I was zooming in and checking two items. I took these two capacitors. So C31, which is the silver guy just here, and then C26 here. Now C26 was actually in the original thing this 15 picofarad mica capacitor. Now I don't actually have a 15 picofarad capacitor, mica capacitor. So C26, if we have a look at the actual documentation here, the little troubleshooting sheet. Let me bring that over. Let's see if we can see this here. So if you roll off at the high end, which is what we're seeing. Remember that what we were seeing here was up at the high end, this signal rolling off. So, and clearly there's movement outside my house. My alarm system, my dog's has gone off. But what you see here is it says to change the size of C26, and C26 is this capacitor that's here, and I'll get to what these two are at the moment. These are supposed to be from 10 to 22 picofarad, and so the one that I had before was this guy here, and this was a 15 picofarad, and that gave us that roll off that we saw here with the signal rolling off. Now, I don't happen to have that, but what I did have was a couple of these little packs of ceramic disc capacitors. And so by taking a 15 and a 4.7 and just putting them in parallel, and as we all know, when you put capacitors in parallel, you can add the capacitance up. What I was able to do was to effectively make a 19 or a 20 picofarad cap that would go in there. And these holes are old enough that you can actually, the holes are quite large. If we look at like the if you look at like the leads on this capacitor here, they're quite substantial, especially compared to, you know, the leads on here. So I was just able to poke both caps through the hole in the PCB and then solder them in. Now, while I was doing that, I noticed something else, and what it was over here on this resistor, somebody had gone in and put whatever this is, and I think it's an old cap of some format, but they put that across this resistor here, and I don't know if that was contributing to the signal variation. It's unclear to me what they were trying to achieve by doing that, but it clearly wasn't original. So, you know, I took that out and I replaced it with the 5.6 ohm 1% resistor that it's supposed to be. And so now we're back, you know, close to sort of normal. These resistor values are what the schematics say, and these two are within range here. And so that gave me the opportunity now to retune the system. So let's have a look at where we ended up in terms of the retuning. So let's just zoom back out, and we'll go to the 40 dB level, and we'll grab the screenshot there. And so now, if we compare that to the 40 dB level that we were previously, you can see that, you know, we still have this characteristic curve in here, but now at the high end we don't have the roll off. We have this essentially becoming flat. And if I had the slug in L3 here, I could possibly get the this curve to flatten out as well, and get it much closer. But here you can see, you know, the spec at the 40 dB level is that we are on 40 dB gain plus or minus half a dB, and so you can see that we're well within spec, a little close here, but we're within spec across the entire frequency range. Now the other problem I was having was not really with the 40 dB, because if you looked at the 40 dB signal here, you can see that, yeah, I was close, but, you know, only just out of the half dB range there. It really came when we did the 20 dB, and as you can see, the 20 dB, it really dropped off at the end there. So let's go and shift this to 20 and update the image, and let's take a look and see what it looks like. Now at 20 dB, the spec is plus, you know, the 20 dB line plus or minus 1 dB. So this is half dB a unit here, division here. So we're well within spec. So going and replacing that capacitor there, and then returning this to normal has really enabled me to get the unit within spec. I'd love to have that flatter, but I'm going to have to see if I can replace L3 with an adjustable inductor here, because I will need to tune out some of those curves. Anyway, that was just a quick video of bringing the gain across the frequency of my 461A instrumentation amplifier back into to spec. So I hope you found that interesting. Catch you later. Bye.